Hi, this is Maggie Vires, and this is my presentation on Chapter 15. So, the body has 3 lines of defense, and when we're talking about the 3 lines of defense, this is basically how the immune system protects us on different levels. So, the first line of defense includes the physical and chemical barriers of the skin and mucous membranes and secretions like saliva and tears. So, these barriers are mostly nonspecific, meaning they defend against any potential invader rather than targeting one specific organism. So the goal is to prevent pathogens from entering the body in the first place. But once something breaches those barriers, the second line of defense kicks in. So the second line of defense includes inflammation, phagocytosis, fever, basically processes that are still nonspecific but are more internal. And then finally is the third line of defense, and this is where we see adaptive immunity involving T cells and B cells that respond specifically to unique antigens. And this gives us long-term immunity and basically remembers the pathogens, invaders for future protection. And together, the 3 lines of defense help work together and keep us healthy. So now I'm going to talk about markers. So a marker is also called an antigen, and they basically have these chemical tags on their surface of the cells, and these are often proteins or sugars that help the immune system tell self from non-self. So the immune system will constantly scan for these markers to determine what belongs in the body and what doesn't. So when a foreign marker is detected, the cell is flagged for destruction. Markers play a huge role in innate and adaptive immunity. Phagocytes in innate defenses use pattern recognition receptors called PRRs, and they use these to help identify PAMPs or pathogen-associated molecular patterns on microbes. So in adaptive immunity, T and B lymphocytes depend on recognizing self-specific antigens to trigger targeted responses. So markers are essentially tell the immune system who's passive and can go or who needs to be destroyed. So the immune system isn't one single organ. There are many organs spread throughout the body, and it depends on multiple systems, including the circulatory system, which transports immune cells and signaling molecules, and the lymphatic system, which filters fluids and allows for immune surveillance. And then together, these systems ensure that immune cells will move quickly and get to where they need to be. So the mononuclear phagocyte system, this is called the NPS, and this is another key part, and it's basically a web of connective tissues that contain macrophages and dendritic cells, and they will patrol the tissues and are ready to engulf any pathogens that will enter, and these systems work together to basically create a defense network. So I'm going to talk about the lymphatic system. The lymphatic system acts as the body's secondary circulation, and it's composed of lymphatic vessels, and they carry lymph only one way towards the heart. And this is like a fluid containing white blood cells, debris, and pathogens. So one way towards the heart, and it relies on skeletal muscle movement for circulation. The system's main roles are to return extracellular fluid to the bloodstream, to drain inflammatory sites, and to also provide immune surveillance through lymphocytes and macrophages in lymph nodes. So this is closely tied to the circulatory system since lymph will re-enter the blood through subclavian veins, and its dual role supports fluid balance and immune defense. So in innate immunity, white blood cells are the first responders. So these are the main types of these are neutrophils, eosinophils, and macrophages or monocytes. So neutrophils will rush to the infection sites for phagocytosis. Eosinophils will handle parasitic infections and help regulate inflammation. And then macrophages, these engulf the pathogens and other immune cells. So white blood cells can fall into two categories, granulocytes or agranulocytes. And granulocytes will contain visible granules, whereas agranulocytes don't. And these cells will circulate through the blood and tissues and basically form the first wave of defense before the adaptive immune system activates. So now I'm going to talk about the mononuclear phagocyte system, or MPS. So this is a framework connecting immune cells across tissues and organs. And it is made up of connective tissue that houses phagocytes, basically macrophages and dendritic cells, and they're located in different organs like the spleen, lymph nodes, thymus, or mucosal tissues like the gut or the lungs. And when pathogens enter, macrophages and dendritic cells will act immediately. But many are resident cells like Kupffer cells. They stay in one place. These are in the liver or the microglia in the brain. And they constantly monitor things entering the body and help with antigen presentation. So maturation of T and B lymphocytes. So both of these develop in the bone marrow, but B cells mature there and gain surface markers, but then they will move to secondary lymphatic organs like the spleen or the lymph nodes. And T cells are different because they will mature in the thymus, and then they gain antigen specificity, and each T cell will become able to recognize one specific antigen. So once they mature, they'll migrate to secondary lymphoid organs for activation, and this maturation process makes sure they're fully functional before they enter the adaptive immune system. So cytokines are the immune system's messenger molecules. They are small proteins that are secreted by immune cells, and they help coordinate the activity. So they regulate inflammation, cell development, and immune communication. So key producers include macrophages, lymphocytes, and endothelial cells. So some cytokines are pro-inflammatory, like the interleukin-1, and it will recruit immune cells to infection sites, but others are anti-inflammatory, like the interleukin-10, and it'll help prevent tissue damage. So these signals help ensure the immune system responds and keeps a good balance in controlling inflammation, but keeping everything controlled as well. So the body's first line of defense is the body's constant built-in protection from microbes entering, and it's always active. It's always part of our structure, and these defenses include the skin, like we talked about before, mucous membranes, and chemical secretions like acid, enzymes, and there are also even beneficial microbes that live inside or on us. And what's important here is that it's not specific to the first line. Like, it doesn't target any specific pathogens, but instead it blocks all invaders generally, because some still manage to bypass the outside defense. But when this happens, the body will activate deeper immune responses like inflammation or adaptive immunity. So when we break down the first line of defense, we can see that it has three main parts. So the physical barriers from the body's exterior, these are things like skin, mucus that keep invaders out. Then the chemical barriers add another layer. So these help by killing or inhibiting microbes through substances like enzymes or acids. But then there is the microbiological barrier. This is usually overlooked, and it includes our own beneficial bacteria. And these have microbes located, and they compete for space and nutrients, which keeps pathogens from being able to hold on here. So even though they all work differently, they do work together to protect us before the immune system is even able to get involved. So several of our body systems are constantly protecting us. We talked about the skin, but there's also the respiratory system that traps dust, microbes in the mucus and clears them out through coughing or sneezing. And the digestive tract also uses acids and enzymes to kill microbes. And then we have the urinary and reproductive tracts that help maintain cleanliness by flushing out the pathogens. And we also have the genitourinary, which includes the urine and vaginal secretions. So I'm going to talk about, I'm skipping this because I don't have time. I'll go over it. The skin we've talked about this, is our most important physical barrier because it has many different layers and it's the first line of defense. So the top layer is thick and full of keratin and it keeps it water resistant, and this structure keeps most pathogens from ever making it inside. But when they go, they take surface microbes with them. And even the body's hair follicles and sweat glands contribute by continuously trying to flush the material outward and away from entering the skin. So this is one of the first systems that we see. But then there is the mucous membranes, and these have moist linings, and they cover many internal structures. So they act to trap and catch microbes using mucus. And then we have the respiratory tract. This has an additional layer of defense because it's lined with cilia, which is tiny hair-like follicles that sweep the mucus upward so it can be swallowed or coughed out. And tears and saliva also continuously wash the eyes and mouth. And also, while vomiting or defecation, these can physically expel any unwanted materials. So we have chemical defenses that we talked about, the physical barriers of the body. Now we can talk about the chemical defenses. So there's like sebum and sweat that keep our skin lubricated. So they also contain antimicrobial things in it that will kill or inhibit microbes. And so this is like enzymes like lysozymes, or they will directly attack bacterial cell walls and protect tissues like in the eyes or mouth. And in the gastrointestinal and reproductive tracts, these rely heavily on chemical defenses. So the stomach's acid is very potent and kills most swollen microbes, but then there's also bile and vaginal acidity that help prevent microbial overgrowth. So now I'm going to talk about the role of the normal microbiota. So this is the collection of microbes that naturally live on us and inside us, and they play a major protective role. So they prevent harmful organisms from taking hold or occupying space, and they consume nutrients and even release chemicals. And this is competitive exclusion, which is a crucial part of the first line of defense. So our microbiota, we've learned that they train our immune system to respond appropriately. So when we overuse antibiotics or sterilize our environments too much, this can disrupt the relationship and lead to problems like inflammation or autoimmune disorders. So some microbes are essential for maintaining a healthy microbiome. So the first line of defense provides protection all the time, but it's not perfect. So damage can happen to the skin or mucous membranes from burns or injuries or blockages, and this can make the body more vulnerable to infection. And many pathogens possess virulence factors that help penetrate or evade these barriers. So when that happens, the body will shift into deeper defenses like inflammation or adaptive immunity. So the first line of defense is essential, but it works best with the other defenses. So I'm going to talk about the steps of inflammation. Inflammation is the body's local response to injury, whether it's infections, trauma, or toxins, and it's marked with classic signs. So there's rubor, which is redness, calor, which is heat, tumor, which is swelling, or dolor, which is pain, and these are all caused by vasodilation and increased vascular permeability. So these changes allow immune cells and plasma to flood the site, and this forms edema and starts the cleanup process. So fever can be good because I'm going to talk about fever. This is a response that raises the body's temperature through signals from the hypothalamus. So it's triggered by pyrogens, which can come from pathogens or immune cells, and these pyrogens reset the body's thermostat, leading to heat conservation